Hello friends, welcome to Risingpearl.com. Today we are talking about series 3 where we are learning trigonometry. Friends, this is webisode number 3 and today's topic is what is meant by trigonometric ratio of an angle. So friends, let's look into it. Very briefly, I hope that you're following us along, friends. I know that in our webisode 1 we did an introduction of trigonometry, where we learned that trigonometry is really a branch of mathematics that deals with study of relationship between angles and sides in a triangle. Then episode 2 we looked at we can really draw a triangle in infinite number of ways, but why we should actually focus our attention on right triangles as a starting point. And now today we are going to learn about trigonometric ratios of a triangle. So friends, here now let's imagine that we have a right angle triangle, which is a right triangle, angle B 90 degrees. Now if you look at angle A and angle C, we know that for any triangle, angle A plus angle B plus angle C, sum total of three angles must be 180 degrees. We know that because there is a theorem. Sum of three angles in a triangle is 180 degrees. We learned that in class 9 or our last season. Now let's write angle A plus for angle B let's put 90 degrees because we know this is a right angle, plus angle C. So we get 180 degrees. Then from here we can say that angle A plus angle C, we are going to take the 90 degree to the other side of the equality sign. So this will be equal to 180 minus 90 degrees, right? Which will be equal to 90 degrees. So friends, here if you look at angle A plus angle C, they both put together is 90 degrees. That means each of the angle by themselves is less than 90 degrees. So we have angle A actually less than 90 degrees and angle C less than 90 degrees. The reason we are saying this, friends, is because both of them, when you add them, right, when you add them you get 90 degrees. So each one of them cannot be really 90 degrees or more. That means angle A and angle C are acute angles. So friends, we talked about in the last webisode that we want to understand the world of trigonometry in the context of right triangles. So this is very important that for this series that we understand whenever we draw a right triangle, the other two angles are really acute angles. One other thing about the right triangle, friends, is we learned that if angle B is 90 degrees, then the side which is opposite to angle B is called hypotenuse. This is hypotenuse, and there is a very famous theorem about hypotenuse and other two sides called Pythagoras theorem. So we have seen what is a Pythagoras theorem. I hope I have spelled it correctly. And we have seen the actual proof of Pythagoras theorem many times. So Pythagoras theorem states that the hypotenuse square, which is AC square in our triangle, AC is the hypotenuse, is sum of squares of other two sides. So other two sides would be, so if this is hypotenuse, other two sides are AB and BC, right? AB and BC are the other two sides because hypotenuse is equal to AC. So AC square is equal to AB square plus BC square. Again, friends, we are going to be using this Pythagoras theorem over and over again in this series, so I just wanted to get it out of the way. Now let's focus on trigonometric ratios of a angle. So one thing, friends, that you have to understand is whenever we talk about trigonometric ratio, question is it is about what? Trigonometric ratio of a side, it is of an angle, it is of a triangle, what is it? So trigonometric ratio is always about an angle inside a triangle. So here we have drawn our right angle triangle or right triangle, angle B 90 degrees. And friends, as you can see, we are drawing the right triangle in this way. It doesn't have to be this way. You can draw a right triangle whichever way you want. right? So the other thing is, so here let's talk about trigonometric ratio of a of an angle, and let's use angle A as the angle that we want to find the trigonometric ratios of. Now there is one thing which is very important to understand, friends, which is this, that which side is adjacent to the angle and which side is opposite to the angle. So let's write it here. We want to find out adjacent side to the angle, and we want to find out the opposite side to the angle. So how do we know which is what? So clearly AC is our hypotenuse, we know that. Now the way to find out this is, because we are talking about angle A, imagine that you are standing in angle A, right? So something like if you are standing here and then this is your base, so this is the ground, or this is AB where you are standing. So the side which is right next to you is the adjacent side. So this side, which is basically AB, this becomes your adjacent side. The literal meaning of the word adjacent, friends, is right next to you, right? So this is your adjacent side for angle A, and the opposite side is the side which you are, if you are standing here at the vertex A, then you will be looking right across from you to the side BC. So the side BC is the side which is opposite to you, or opposite to angle A. So in other words, at A, adjacent side to angle A will be AB, like we just discussed, and the opposite side to angle A will be BC. So AB becomes your adjacent side and BC becomes your opposite side. And again, these things are always in relation to the angle. So this is for angle A, this is what we have, right? Because if I am standing at angle A, then this is the adjacent side right next to me, and this is my side which is opposite to me. Now for example, let's talk about same triangle again. We have angle B 90 degrees. Instead of A, this time let's try to find out for angle C what is going on. Instead of angle A, we are going to focus on angle C. So this time you have to imagine that you are standing at vertex C and you are looking right across from you. So then this becomes the side opposite to you. For angle C, AB is the side opposite to you, and the side which is right next to you where you are standing is the side BC, right? So in that case, if you were to write it this way, we are going to write that the opposite side to angle C is AB and the adjacent side is BC. So just wanted to make a point here that, friends, if you think about the side, if you just think about the side AB for a moment, right? In the first case for angle A, AB was the adjacent side. It was the adjacent, I think, we misspelled it. So whatever, I think you get the point. AB was the adjacent side, but for the second case here for angle C, the same AB is now really the opposite side. So the point I'm trying to make, friends, is that it is important to know these two things. Whenever we talk about trigonometric ratio, we are always talking about an angle. And in order for us to understand the angle, we really want to know adjacent side for that angle and opposite side for that angle, right? Now let me explain to you that what are these trigonometric ratios of an angle. So if my angle B is 90 degrees and if this is my angle A, there are, friends, a total of 6 trigonometric ratios. What are they? First, sine of angle A. Second, cosine of angle A. Third, tangent of angle A. Fourth, cosecant of angle A. Fifth, secant of angle A. And sixth but not the last but not least, cotangent of angle A. So I want to draw your attention to the fact that all of the 6 trigonometric ratios, each one, this, sine, cosine, tangent, cosecant, secant, and cotangent. Each one of them is a trigonometric ratio, and each one of them, all of them are actually for angle A. Like I said, trigonometric ratio by itself does not make sense, but it has to be of an angle. Each one of them are trigonometric ratios of angle A. So as you can imagine, any triangle has three angles: angle A, angle B, angle C, and angle B, right? So I have angle A in a triangle, I have angle B, and I have angle C. Any triangle will have three angles. So each angle will have 6 trigonometric ratios. So just wanted to explain this point, that the trigonometric ratios, we still don't know what they are, but there are 6 trigonometric ratios, and these trigonometric ratios are for each angle, right? So let's continue to explore this. Now we will look into the point that we were trying to make earlier, which is that whenever we talk about trigonometric ratios, we are talking about an angle. So here let's start with for angle A. So this is our 90 degrees. Now for angle A, we want to write out the trigonometric ratios for angle A. So we just talked about the adjacent side and the opposite side. So what is the adjacent side for angle A? That will be AB. So the side which is right next to angle A is AB, and the side which is right across from angle A is opposite is BC. This is BC. And we know that hypotenuse is AC. This is the hypotenuse, AC. Now let's write the trigonometric ratios for angle A. So first is sine of angle A. Sine of angle A. Sine of angle A is defined as the ratio of side opposite to angle A divided by hypotenuse. So the side opposite is BC. So sine of angle A will be expressed as ratio of BC divided by hypotenuse, which is AC. So for the first time, friends, we have sine of an angle equal to expressed as ratio of two sides of a triangle. So this is very, very important. So this is our first trigonometric ratio. Sine of angle A equal to BC by AC, that is opposite side to angle A divided by hypotenuse. Similarly, let's go ahead and write the cosine of angle A. This is our second ratio. Cosine of angle A is defined as the ratio of side adjacent to angle A divided by hypotenuse. What is the side adjacent to angle A? That will be AB. So cosine will be defined as AB divided by hypotenuse is AC. Now friends, the next ratio, or our third ratio, is tangent of angle A. So tangent of angle is defined as side opposite to angle A divided by side adjacent to angle A. So if you think about this, so side opposite to angle A is really BC. So this will be BC divided by AB. And now we will write the rest of the three ratios. So the fourth ratio is cosecant. Cosecant of angle A is equal to, it is the inverse of sine of angle A. The first ratio was sine of angle A. So cosecant is 1 by sine, or 1 by sine of angle A. So which will be, basically, so hypotenuse is first, AC divided by BC. So it will be just the opposite of sine. Sine was BC by AC. This is AC by BC. Next, fifth trigonometric ratio is secant of angle A. This is the reciprocal of cosine of angle A. So which will be equal to hypotenuse divided by side adjacent to angle A, or we can write this one as hypotenuse again is the numerator AC divided by the adjacent side is AB. And the last but not the least is the cotangent of angle A. This is the inverse or reciprocal of tangent of angle A. So this will be equal to side adjacent to angle A or AB divided by BC, which is the side opposite to angle A. So friends, for the first, so this will be your number 6. So the first three ratios are, we saw those ratios separately, and the second set of three ratios, which is cosecant, secant and cotangent, they are really the inverse of sine of angle A, cosine of angle A and tangent of angle A respectively. So friends, this is what is meant by ratios of trigonometry or trigonometric ratios of a particular angle. So all of these are for our angle A. So 6 trigonometric ratios of our angle A are sine of angle A, cosine of angle A, tangent of angle A, cosecant of angle A, secant of angle A and cotangent of angle A. Friends, here we live in the world of Twitter and Facebook and all that, LOLs, right? So we don't like to have a lot of long words or sentences. So essentially, sine of angle A is really written as sine angle A, or also this is abbreviated as you will see later on, is just sine angle A or sine A. Similarly, cosine will be written as cos angle A or cos A. Tangent is written as tan angle A or tan A. Essentially, we will also drop the angle symbol from here. But I just wanted to highlight that we are not going to be using sine of angle A or cosine of angle A or tangent of angle A. Almost always you will see that instead of using cosecant of angle A, we will be using cosec angle A. Similarly, secant of angle A will become sec angle A, and cotangent of angle A will become cot angle A. So essentially, so cos, this, let's try to write it here. Eventually we will write this as cos A. This we will write this as tan A. This we will write this as, just the angle will become this, the letter A. So cosec, we will give a space A. This will be sec space A, and this will be cot space A. While we are talking about how we write it, this is important, friends, to understand that when we say sine A, it does not mean that this is sine multiplied by A. This interpretation is absolutely wrong, because this is almost, so sine space A, it does not mean you take the word sine separately and multiply that by A, right? Remember that sine A is one word, so sine space A, and this is expressing a trigonometric ratio. Similarly, suppose you want to write 2 times this. So the way you're going to write that is you're going to say 2 multiplied by sine A. Because the point is that you have to always remember sine A, which is nothing but sine of angle A or sine of angle A. This is one thing. This is one unit which is representing a trigonometric ratio of an angle. So if you have to write 2 times this, you will write it this way. Similarly, if you have to write, for example, cos A square, so you have to write it as cos A square. For the square or the cube or any power, it is also written as cos square space A. And we will see this form many times in our future webisodes. But I just wanted to highlight to you that when we write the ratios we express them in these formats. So friends, finally, what we have done in this webisode is that we have taken a look at right triangle, and we have expressed the trigonometric ratios of acute angle. Remember, like this angle A and angle C, they are acute angle. We have expressed the trigonometric ratio as relation between angles and sides. In the next webisode, we are going to continue to learn more about trigonometric ratios of angle.